Hi everyone, I welcome you once again back to my channel. So in this video we are going to look at the logical operators in C++. So when we talk of logical operators, they are operators that determines the logic between variables or values, and basically they actually result in a boolean, either true or false. Alright, so we actually have three basic types of the logical operators. We have the AND, logical OR, and then a logical NOT. Alright, so I actually had to. Alright, so the logical AND is determined by a double ampersand sign, and then the OR is determined by straight strokes 2, and then NOT is determined by an exclamation mark. So how they specifically work is that the logical AND works in a way such that returns true only if both of the statement conditions are true, and then it will return false if even one of them is false or both are false. Okay, and then if you don't get it, you don't worry, you actually get into it. So with some examples so that you get the understanding much. And then the logical OR also works in a way that it returns true if there is a true statement. All right, so for the true statement, if one is true, it is going to return true. If both statements are true, it's going to return true. And then it only returns false if all the statements are false. Okay, so that's how the logical OR also works. And then the logical NOT actually also depends on one statement condition, and then it just reciprocates the statement, like the result of that statement. So if maybe I have a male and then I do not male, then it means I'm having a female. So it actually works in a way that if it is not true, not true gives false, and then not false will also give true. So it actually gives the opposite or the reciprocate of the other one. Alright, so we will dive into it with some examples so that you see what we are actually talking about. So I'm actually going to use something like an access system for students in K University. So before you could access it, you have to have your index number and then reference number. Okay, so I'm not actually going to do validation, but we will just check the number, the length of the number each person is going to type, so that we could say that this is a valid index number and this is a valid reference number. Okay, so K University, our index number is 7. It has a length of 7, and I think the reference number is also 8. All right, so I'll create a string over here, and I'll do index number and also reference number. I'm using camel casing here. You have no idea about it, you can go back to the previous video and watch about that. So I'll just do a cout, say enter your index number, and I'll see you receive the index number from the person. I was confused. Okay, and then I'm actually going to copy this and paste it. So instead of index number, we are going to use the reference number over here. Alright, so receive the reference number here. So this is where we are going to do the logic. So I'll say if index number dots length. Okay, so that's how we used to check the length of a value or a string. This is the length of a string. That's why I use a string as the data type over here, but actually we are going to receive integers. So if index number dot length, it is a method, so you have to bring an empty parenthesis at the end, is equal to 7 and percent reference number dot length. I want this one to dot length is also equal to 8. Alright, so I have these two statements conditions that if index number dot length is equal to 7 and reference number dot length is equal to 8. So what I mean over here is that if the length of the index number the person will input is exactly 7, and then also the reference number the person inputs is exactly 8. So in this case we are to receive both of them. All right, we have to receive both of them. So if this condition is true and then this one too is true, then we can go ahead and then execute our program that, let's say, access accepted. Alright. Yeah, so I can do something like access accepted. So you could see that we should probably have an else statement over here, so that if it doesn't happen, so you have this here, say access denied. Alright, so we have this block of statements. Okay, so there's the condition that if the number of index number the person enters is equal to 7, and then the and, because this end, so the end means that this and this have to be true before we could execute the first statement. That's the true. Otherwise we are going to execute the second statement, that's the false. Okay, so let's go ahead, build and run again. Okay, so we got it working. We say enter your index number, so I'm going to go the right way. So 1 2 3 4 5 6 7. Enter your reference number 1 2 3 4 5 6 7 8. Alright, so you can see we have access accepted. Okay, so let's build and run again, and let's change it to something different. So enter index number, say 1 2 3 4 5. Enter reference number 1 2 3 4 5 6 7 8. Boom, access denied. So you could see that even though the reference number we have the total amount we are actually expecting, but because the index number was not up to that, we got denied. All right, so that's how the logical AND works. So it is, the result is only true if both of the statement conditions are true. All right, so let's do that for the OR also. So I am just going to replace the AND with an OR. Okay, so what the OR is also going to do is that if we have any of them to be true, then the result is going to be true. So it is only false if both of them are false. All right, that's how the OR also works. So the OR is like an opposite to the the AND, because the AND is only true if both of them are true, and then the OR two is only false if both of them are false. All right, so with this, let's say build and run, and let's see what happens. So it says enter your index number. So I'll do 1 2 3 4 5 6 7. Enter reference number 1 2 3 4 5 6 7 8, and then boom, access accepted. Let's reduce the index number. So I'll say 1 2 3 4 5. Let's 1 2 3 4 5 6 7 8, and then boom, we still have access accepted because we got one of the statement condition to be true. Okay, so that's how the OR also works. So we already said that the work of the NOT is that it reverses the results in such a way that if the result is true, it is going to reverse to be false, and if it is false, it's going to be reversed to be true. So let's demonstrate that, and then I will clear this off. We don't need it anymore. This one as well, and then this place. All right, perfect. So we only have the index number. Okay, so if index number dot length is equal to 7, then we say access accepted. Otherwise, we say access denied. That is when it is less than 7 or more than 7. Okay, so I am going to put this statement in a parenthesis. Then I'll bring my NOT symbol over here. It always comes before the value of the variable over here. So in this situation, if the user inputs exactly 7, a length of 7 digits, we are expected to get this statement, alright, because it is true that the value entered is 7, but because of the NOT, it's going to be reversed in such a way that we are going to get the false statements. Okay, so that's how it works. It reverses the results. All right, so let's save this, build and run, and I'll do enter index number. So I'll do 1 2 3 4 5 6 7, and then press enter, and you could see we have access denied. Why did we have access denied? Because it has the actual answer should have been access accepted, but because of the NOT, we reversed it to be false. And then let's demonstrate this, build and run, and I will do 1 2 3 4, enter. You could see access accepted, but from the logic we said if it is not up to 7, we should do accept denied, but because of the NOT, we are having access accepted. So the NOT always reverses the state of the statement, either true or false. All right, if you have found this video helpful, please do me a favor by subscribing if you haven't yet, and also share for others to know. Help me, like, yeah, I really beg you. And then subscribe as well, share, and yeah, whatever. See you in the next video.